In this video particularly, we are going to discuss about how we can find time complexity of any non-recursive programs first. Then we'll see the recursive programs also. So first example, very basic one, main. Let's say x equal to y plus z. So आप बताइए मुझे what will be the time complexity of this. So it's simple because this statement is going to execute one time only, one time execute. So we can say order of 1, or you can say big O of 1, or you can also say constant time complexity. Constant time means ना कोई भी ऐसा नंबर 1 टाइम, 5 टाइम, 10 टाइम, 100 टाइम, 1000 टाइम और एनी बिग नंबर है ना 1 बिलियन टाइम, वो सब कांस्टेंट टाइम कॉम्प्लेक्सिटी के अंदर आते हैं. वी कैन से ऑर्डर ऑफ 1 और कांस्टेंट टाइम कॉम्प्लेक्सिटी. नो मैटर व्हाट बिग नंबर इट इज, like 1 trillion times this statement is going to execute, but that trillion is fixed, that is a finite number, then it is going to be a constant time complexity order of 1. So next example हम लोग देखते हैं. Let's say main x equal to y plus z for I equal to 1, I less than equal to n, I plus plus. X equal to y plus z. Bracket close, close. Okay, you can pause the video and if you want to try, you can try. So if you see one time, ये statement one time execute करेगा. This statement also one time. This statement is going to execute n plus 1 times. How? I less than equal to n. Just assume कीजिए कि let's say n equal to 5. I का starting value क्या है? I 1 less than equal to 5. Condition check. Yes, it is true. Then I will increment by 1 because I plus plus. So 2 less than equal to 5. Yes. 3 less than equal to 5. Yes. 4 less than equal to 5. Yes. 5 less than equal to 5. Yes. 6 less than equal to 5. No. Then only this condition will break. Then the control will come out from the loop. Right. So यहाँ पर अगर आप देखें 1, 2, 3, 4, 5 times true. 5 times true. That is why this statement is going to execute 5 times. If we consider n equal to 5. But n times, so that means n times true. This statement n times true. And जब n plus 1 times होगा, so it will become false. So that means total n times this statement will execute. And this I plus plus is also n times will execute. Right. So total time complexity, if we say, total time complexity क्या होगा यहाँ पे? First statement 1 time. Next this I 1 times, then this condition n plus 1 times, then this I plus plus n times, and then this statement n times. So total is 3n plus 3. Right. So 3n plus 3, whatever this number, big O of n we can say. Why? Because ये जो big O notation है ये इस informations को carry करता है. जब हम लोग definition इसका discuss करेंगे, right, तो वो बिगो रिप्रेजेंटेशन ही ऐसा कैरी करता है कि जो भी कांस्टेंट टर्म है ना उसको आप इग्नोर कर सकते हैं, बिकॉज दिस कांस्टेंट टर्म वी कैन इग्नोर. सो नेक्स्ट एग्जांपल, लेट्स से मेन x इक्वल टू y प्लस z फॉर I इक्वल टू 1, I लेस देन इक्वल टू n, I प्लस प्लस. x equal to y plus z for I equal to 1, I less than equal to n, I plus plus. then again for j equal to 1, j less than equal to n, j plus plus x equal to y plus z. You can try, आपको टाइम कॉम्प्लेक्सिटी फाइंड करना है. ओके, सी दिस स्टेटमेंट इज गोइंग टू एग्जीक्यूट वन टाइम, एंड अभी प्रीवियस एग्जांपल में हम लोगों ने डिस्कस किया है अबाउट दिस स्टेटमेंट, इट इज गोइंग टू एग्जीक्यूट n टाइम्स, राइट. एंड देन इफ यू टॉक अबाउट दिस फॉर लूप, i इक्वल टू 1, i लेस देन इक्वल टू n, i प्लस प्लस, मीन्स ये फॉर लूप 1 से when I equal to 1, then 2, then 3 and so on, it will go till n. That means n times, right? Or for each I, when I equal to 1, j is going to do from j equal to 1 to n, means n work here, because this statement will execute n times. For each I, when I is 1, this statement is execute n times. When I is 2, again this for loop will run n times. When I is 3, n times, right? So when I is 2, again n work. When I is 3, again n work. When I is n, again n work. So that means what we can say, ये जो loop है n times n work, n times n work. This n work is done n times, right? So it is going to be n square, n times n work, n into n, n square. So total time complexity अगर हम लोग बात करें, so 1 plus n plus n square. Now what we can see, this n square is higher term, so we can say big O of n square or order of n square. Why? Because again see, whatever this number will represent, n square plus n plus 1, you can write 2n square. So it is coming under that, and 2 is just a constant number, because we are talking about the approx answer, a priori analysis, right? So order of n square or big O of n square is going to be the time complexity for this program. So let's say I'm going to change this n by 2 upon j is going from 1 to n upon 2, then what will be the time complexity? You can try and then you can put your answer in the comment box. So see, इसमें तो कोई चेंज है नहीं. एक बार ये n टाइम्स, इस लूप में क्या बात था, पहले ये 1 to n चल रहा था, बट अभी क्या है, अगेन i is going from 1 to n, and for each I this loop is going to execute n upon 2 times, right? When I equal to 1, n upon 2. When I equal to 2, n upon 2 work. When I equal to 3, n upon 2 work, and so on. When I is n upon 2 work, because j is going from 1 to n upon 2. So that means n times n upon 2 work. So total is n square upon 2. So finally अगर टोटल टाइम कॉम्प्लेक्सिटी की हम अगर बात करें, तो 1 प्लस n स्क्वायर अपॉन 2, 1 प्लस n स्क्वायर अपॉन 2. बिगर टर्म इज n स्क्वायर अपॉन 2. So this thing we can write 1 upon 2 into n square. So again big O of n square, because constant 1 upon 2 we can ignore. Let me do one more change. Let's say n upon 2. I is going from 1 to n upon 2 and j is also from 1 to n upon 2. Then what will be the time complexity? Okay, so let's say n upon 2. So यहाँ पर क्या चल रहा है? I का क्या है? 1, then 2, then 3 and so on. कब तक? n upon 2 वर्ग तक. And for each I, j is going 1 to n upon 2. That means n upon 2 work. When I is 2, again n upon 2 work. When I is 3, again n upon 2 work. When I is n upon 2, again n upon 2 work. जैसे ही I n upon 2 plus 1 होगा, it will break the condition and it will come out of the loop. Right? जैसे ही I n upon 2 plus 1 होगा, next time it is going to be आउट ऑफ द लूप. सो यहाँ पर n अपॉन 2 टाइम्स ट्रू, n अपॉन 2 प्लस 1 टाइम पे फॉल्स, राइट. सेम यहाँ पे भी. सो टोटल टाइम कॉम्प्लेक्सिटी इस लूप का क्या रहेगा, n अपॉन 2 टाइम्स n अपॉन 2 वर्क, दैट मीन्स n स्क्वायर अपॉन 4. फाइनली टाइम कॉम्प्लेक्सिटी की अगर हम लोग बात करें 1 प्लस 1 यहाँ से n फॉर दिस लूप एंड देन n स्क्वायर अपॉन 4. बिगर टर्म इज n स्क्वायर अपॉन 4. फाइनली वी कैन राइट 1 अपॉन 4 इंटू n स्क्वायर. कॉन्स्टेंट वी कैन इग्नोर एंड वी कैन राइट ऑर्डर ऑफ n स्क्वायर और big O of n square. Time complexity for this problem. Example 4. Mean x equal to y plus z for I equal to 1, I less than equal to n, I plus plus, x equal to y plus z, x equal to y plus z. Now tell me what will be the time complexity. ये स्टेटमेंट वन टाइम एग्जीक्यूट होगा, राइट. और यहाँ पर पहले हम लोगों ने डिस्कस कर रखा है n टाइम्स इट इज़ गोइंग टू बी ट्रू, n टाइम्स इट इज़ गोइंग टू बी ट्रू, एंड जैसे ही n प्लस 1 टाइम्स ये होगा तो ये हो जाएगा फॉल्स, लूप से बाहर. सो n टाइम्स ट्रू मीन्स ये दोनों स्टेटमेंट 2 इंटू n टाइम्स एग्जीक्यूट होगा, राइट. फाइनली टाइम कॉम्प्लेक्सिटी इज 1 प्लस 2n, order of n we can say. So let me change a little bit. Let's say I less than equal to 100. Now please tell me what will be the time complexity. See, this is going to execute 1 times. Now this statement it is going to execute 100 times true. So that means 2 into 100 times, that is 200 times this statement will execute. But what about this? When 101 times पे ये आएगा, this is going to be false. So out of the loop. So what we can say 200 times. 200 times is nothing but constant number. That is why we can say order of 1 or constant time complexity. Next example. Mean while n greater than equal to 1, n equal to n minus 1. आपको बताना है टाइम कॉम्प्लेक्सिटी. यू कैन ट्राई एनी बिगर नंबर n. You can just assume. Let's say n is 5. So again 5 greater than equal to 1, true. 4 greater than equal to 1, true, because n minus 1 is 10. 3 greater than equal to 1, true. 2 greater than equal to 1, true. 1 greater than equal to 1, true. 0 greater than equal to 1, no. So that means 1, 2, 3, 4, 5 times. 5 times true and 1 times false, right, because when n is 5 it is going to be 5 times true and 1 times false, these conditions. So that means this is going to execute n upon 1 times, because each time minus 1 minus 1 minus 1. So finally what we can say, order of n will be the time complexity, or big O of n will be the time complexity. Okay, let me change a little bit here. Let's say each time here n equal to n plus n minus 5. Now tell me what will be the time complexity. So see, जब n equal to n minus 5 है तो यहाँ पर क्या हो जाएगा, n upon 5. n upon 5 times this statement is going to execute. Let's say n equal to 10. So 10 greater than equal to 1, true. Next time minus 5. 5 greater than equal to 1, true. Next time it is going to be 0 greater than equal to 1, false, right? So this way 2 times true, 1 times false. So n upon 5 times. So n upon 5 is nothing but 1 upon 5 into n, and constant term because we can ignore, we can write big O of n will be the time complexity for this problem. So let's say next time n minus 10, then n upon 10 big O of n time complexity. N minus any constant number. N minus any constant number, that means n upon that constant number, that constant c. Then 1 upon c into n. Anyway, this c is constant, so big O of n will be the time complexity. Let's say one more example, 6. Main x equal to y plus z, while n greater than equal to 1, n equal to n minus 50, n equal to n minus 100, n equal to n plus 149. Can you please tell me time complexity of this code? See, this first statement 1 time, right? Clearly 1 times. Then whatever this n here, n, let's say n is having any number, but n का behavior क्या है यहाँ पे? The behavior of n is decrementing. The frequency of decrementing, the step size of decrement can be anything. But ये कर क्या रहा है? Decrement हो रहा है और ये reach कर रहा है 1 को. When n greater than equal to 1. जैसे ही 1 से छोटा होगा, the condition will break. But ये step size की frequency क्या है? तो first time n minus 50, then n minus 100, total n minus 150, but again n plus 149. So implication of all these 3 statement is going to be n equal to n minus 1, right? N minus 1. So finally the total number of times this statement is execute is n upon 1. So that is big O of n. We can say big O of n time complexity or order of n time complexity. Example number 7. Main I equal to 1 while I less than equal to n, I equal to I plus 100. Tell me time complexity of this code. See, इससे पहले एग्जाम्पल में हम लोगों ने क्या किया था? इससे पहले एग्जाम्पल में क्या था? n था और n रिड्यूस हो रहा था, n छोटा होते जा रहा था by 1 by 1 by 1. So that is why n is reaching to 1. That is why माइनस यूज हो रहा था. बट यहाँ पे क्या है? I है 1 and I is incrementing step size, right? By 100, by 5, by 10, by 1. इंक्रीमेंट का स्टेप साइज कैन बी एनीथिंग, कोई भी कांस्टेंट नंबर है, बट इट इज गोइंग टू इंक्रीमेंट ईच टाइम एंड इट इज गोइंग टू रीच n बिकॉज लेस देन इक्वल टू n. जैसे ही n plus 1 होगा द कंडीशन विल ब्रेक. व्हेन i विल बिकम n plus 1 देन कंडीशन विल ब्रेक. सो यहाँ पर हम लोग देखें तो i का स्टेप साइज क्या है ईच टाइम? i plus 100 देन अगेन प्लस 100. तो टोटल नंबर ऑफ टाइम्स जो ये इंक्रीमेंट होगा डेट विल बी n upon 100 बिकॉज ईच टाइम 100 इंक्रीमेंट हो रहा है. जैसे कि अगर लेट से n इक्वल टू 1000 है ना, और i शुरू किया 1 से और हर बार 100 ऐड कर रहा है, तो यहाँ पहुँचने में कितना टाइम लगेगा? 10 टाइम्स इसको स्टेप्स लेना होगा. सो दैट इज वाई n upon 100. सो फाइनली द टाइम कॉम्प्लेक्सिटी विल बी n upon 100. दैट इज नथिंग बट 1 upon 100 into n. Again constant term you can ignore big O of n will be the time complexity, right? So let's say मैं इसमें एक दो और changes कर रहा हूँ. Now you please tell me what will be the time complexity. Let's say I equal to 100, I equal to I plus 100 and I equal to I plus 150. Then I equal to I minus 350. Please tell me what will be the time complexity of this. See, I क्या है? I starting कहाँ से कर रहा है? 1 से. I plus 100 कहाँ पहुँचने के लिए? n के पास. I plus 100 and then I plus 150. टोटल कितना इंक्रीमेंट हुआ? I plus 250, राइट? टोटल. बट यहाँ से I minus 350 पहुंचा कहाँ पे? -100 पे. सो इम्प्लीकेशन इस तीनों स्टेटमेंट का क्या है फाइनली इम्प्लीकेशंस इस I पे? तो I इक्वल टू I minus 100. सो फाइनली इट इज गोइंग टू एग्जीक्यूट -100 जब ये नेक्स्ट टाइम एग्जीक्यूट होगा तो -200, अगेन नेक्स्ट टाइम एग्जीक्यूट होगा -300. सो जो I को n की तरफ इंक्रीमेंट होना चाहिए था, इट इज गोइंग बैकवर्ड. सो दैट मीन्स इनफाइनाइट टाइम्स ये लूप एग्जीक्यूट होने वाला है, राइट? इनफाइनाइट, बिकॉज I जहां से शुरू हुआ था वो n को रीच ही नहीं कर रहा है. n+1 होगा देन ओनली दिस कंडीशन इज गोइंग टू ब्रेक. जैसे ही n+1 या n से जैसे ही ज़्यादा होगा देन ओनली दिस कंडीशन विल ब्रेक, विच इज़ नॉट गोइंग टू हैपन. सो दैट इज वाई इट इज गोइंग टू एग्जीक्यूट इनफाइनाइट टाइम्स, इनफाइनाइट लूप. सो एग्जाम्पल नंबर 9. main while n greater than 1, n equal to n by 2. Let's try to find the time complexity of this code. See, यहाँ पर what you can do is you can assume any big number n, okay, any big number, so that you can iterate 3 or 4 times this loop. So because here n is divided by 2 each time, 2 2 2, and it will reach to 1, right? N is any number that will reduce by 2 by 2 by 2 and it will reach to 1. So that means let's say we are going to take 128 as an n, because each time 2, तो 2 to the power में अगर आप लेते हैं n की वैल्यू, so it will be easy to find the number of times it is going to execute. So when n is 128 greater than 1, yes, then next time it is going to be n by 2. 64 greater than 1, yes, then next time it is going to be 32 greater than 1, yes, the next time 16 greater than 1, yes, then 8 greater than 1, yes, then again 4 greater than 1, yes, 2 greater than 1, yes, 1 greater than 1, no. So you can see 1 2 3 4 5 6 7 times. 7 times this statement is going to execute. 8 times पे this is going to be false, so out of the loop. So if you see this 7 times, when n is 256, this will become 8 times, right? 8 times. So that is why we can say log n base 2, order of log n base 2, or you can also find in this way. Let's say n is any number, so first time n is n, next time it is n upon 2, next time it is n upon 4, next time it is going to be n upon 8, right? So n upon 8 is nothing but n upon 2 to the power q. This is nothing but n upon 2 square, and this is n upon 2 to the power 1. So we can write n upon 2 to the power 0. So if you iterate this loop 2 or 3 times, max to max 4 times, you will find a pattern. Here you can see the patterns. Now if we execute this statement k times, like the same way, k times, so it will become n upon 2 to the power k, right? K times, और कब ये टर्मिनेट होगा दिस लूप, दिस कंडीशन, व्हेन इट विल रीच टू 1, right? So what we can do, we can find this solution, we can find this. So this is nothing but n equal to 2 to the power k. If we are going to apply both side log, it will become log 2 to the power k base 2 equal to log n base 2. So it will become log n base 2 equal to k, right? This k. So we got to know that k equal to log n base 2. So that means this loop is going to execute big O of log n base 2. I'm going to change this n upon 2 to, let's say this is n equal to n upon 20. Then what will be the time complexity? See, first time it is going to be n, next time n upon 20, next time n upon 20 square, next time n upon 20 cube, and so on, n upon 20 to the power k equal to 1, because 1 is the termination. 1 को reach करेगा then only it will terminate. So it will become n equal to 20 to the power k. Again apply log both side, log 20 to the power k base 20 log n base 20 equal to this. So log n base 20 equal to k. So that is how you found this k. So big O of log n base 20 will be the time complexity of this code. Let's say I am going to change a little bit more, n equal to n upon 3. What will be the time complexity of this code? See, what will be the effect of this two statement on n? How this n is going to reach to this 1? Because first time n upon 20 and then n upon 3. The total is n equal to n upon 60, right? So we can say big O of log n base 60. Next example number 10 is main I equal to 1 while I less than n, I equal to 2 into I. Please tell me the time complexity of this code. So you can see previous example में हम लोगों ने क्या किया था, divide, right? Each time जो n था that was divide by 2 and then divide by 2 and it is going to reach 1. So that is why it is coming log n base 2 times this step size, this number of loop will execute. So if you see here the multiplication, now this 1 is trying to reach to n and 1 is multiplied by each by 2, right? तो आप इसको visualize करके you can write big O of log n base 2, but here you can also visualize like this way. First time I is 1, next time it will become 2, next time it will become 4, next time it will become 8, next time it will become 16. So you can say 16 is 2 to the power 4, 8 is 2 cube, 4 is 2 square, 2 is 2 to the power 1, 1 is 2 to the power 0. The pattern is like this only. But कितने number of times and so on, कितने number of times, so let's say 2 to the power k times we are going to execute, then it will reach n, then only this condition is going to break. So 2 to the power k equal to n, if we apply log on both sides, so log 2 to the power k base 2 equal to log n base 2, this will become k equal to log n base 2. So the time complexity is big O of log n base 2, right? If I change this 2 with the, let's say 10, now please tell me the time complexity of this code by changing this tens. So because of this 10 it will become big O of log n base 10. Let's say our next example, example number 11 is main while n greater than 2, n equal to n to the power 1 upon 2. फाइंड कीजिए टाइम कॉम्प्लेक्सिटी. सो सी यहाँ पर यू कैन ऑल्सो विजुअलाइज, लाइक लेट्स टेक अ बिग नंबर. लेट्स से n equal to 1,000. So if you do this first time, n greater than equal to 2, yes. So next time it is going to be root under 1000. So nearly 30, it is going to be 33, nearly greater than 2, yes. Then again root under 33, 5 5 is 25, 6 6 is 36, so nearly 5 point something. So let's say 6 greater than equal to 2, yes. Then root under 6, 2 2 is 4, 3 3 is 9. So 2 greater than 2, no. So you can see 1 2 3 times this statement is going to execute. You can also see in this way. Let's say 1000, if you apply log on this, so it is going to give you 10. If you again apply log base 2, so it is going to give you nearly 3. So this is again 3 times 3 times. You can also visualize in this way. Let's say first time in any big number. First time n is any big number. Next time the condition is when it is true, the n is become n equal to n to the power 1 upon 2. So that means n to the power 1 upon 2. Next time again whatever this number is there, then again n to the power 1 upon 2, n to the power 1 upon 2 square, then again n to the power 1 upon 2 cube, and so on and so on. But कब तक? So when n to the power 1 upon 2 to the power k equal to 2, then only this condition will break. So that means it is going to be, if you apply both side log 2 base 2 equal to log n to the power 1 upon 2 to the power k base 2. So that means log n to the power log n base 2 1 upon 2 to the power k into equal to 1, right? So if we apply this, if we solve this, so it will become log n base 2 and the cross multiplication equal to 2 to the power k, right? So again if we apply log on both sides, so it will become log 2 to the power k base 2, and here log n base 2 पहले से है, and then log base 2. So finally it will become k equal to log n base 2 for the both side, right? So we can say big O of log n and the base will be 2 for this time complexity of the given code. So here you can see this 2 is contributing in the first log base is based on this only, on this 2, because you can see here n to the power 1 upon 2 to the power k equal to 2, because this the condition, this while condition is depending on this 2. When n will reach to this 2, then only this condition is going to break. So that is why here you can see we are equating with this 2. So based on this 2, the first log is going to be happen. See here log n base 2, because to solve this 2 to make it 1, we are applying log. That is why this base 2 is coming from this. And the next time this second log, second, the step size, here you can see 1 upon 2, 1 n to the power 1 upon 2. So the second log is coming from 2 to the power k, 2 to the power k. So from this 2 to the power, it is coming second log. So we can say this 2 is contributing on the first log base, and this 2 is contributing on the second log base is based on this only, right? So now I am giving you one simple example. Try to solve this. let's say our example number 12 is main while n greater than 29, n equal to n to the power 1 upon 25. Now you please tell me what will be the time complexity of this code. See, first time n will be the n, right? N, you can assume any big number. First time n l. Next time n equal to n to the power 1 upon 25. So n to the power 1 upon 25. Next time it will become n to the power 1 upon 25 square. So we can also say n to the power 1 upon 2 to the 25 to the power 0 for the first one. And the next time n to the power 1 upon 25 to the power q. And so on. Kab tak? When this condition is going to break? When it will reach n to the power 1 upon 25 to the power k equal to 29. Because here you can see n greater than 29. जैसे ही it will equal to 29, the condition will break. So we need to solve this. So what we can do? We can apply log on both sides. So log 29 base 29. So log n to the power 1 upon 25 to the power k base 29. Right? So from here, what we can do? Here 1 upon 25 to the power k into log n base 29 equal to 1. Then it will become log n base 29 equal to 25 to the power k. Again we'll apply log both sides. So log 25 to the power k, base will be 25. So here log n 29 is from already there. Then we'll apply log base 25. So this will become k. And here log n, first log is base 29, second log is base 25. Because here you can see first log is based on this, and the second log will be based on this number only. Right? So let's say I'm going to change this statement. I'm going to change this while. Let's say while n greater than 17, n equal to n to the power 1 upon 34. So tell me what will be the time complexity. It is a simple. What you can say? Log n base 17, then again log 34. Big O of this only. By saying this, because first log will be the based on this 17, and the second log will be based on this 34. Right? So this way you can find the time complexity of this kind of problems. Example 13. Main I equal to 2 while I less than n. I equal to I square. Please find the time complexity of this code. See, इससे पहले हम लोगों ने क्या देखा? प्लस देन माइनस, दोनों एक तरह से वर्क कर रहे थे. n जब डिक्रीमेंट होते होते 1 को रीच कर रहा था, वहाँ पे माइनस यूज हो रहा था. जब i इक्वल टू 1 रीच करते करते n को रीच कर रहा था, प्लस यूज हो रहा था. राइट? देन अगेन जब n डिक्रीमेंट होते होते, मीन्स वॉट एवर दिस n इज बिग नंबर, दैट इज रिड्यूसिंग एंड ट्राई टू रीच 1, वहाँ पे डिवाइड यूज हो रहा था, तो लॉग के फॉर्म में आंसर आ रहा था. देन जब i फ्रॉम 1 इट इज गोइंग टू रीच टू n, इंक्रीमेंट हो रहा था, मल्टीप्लाइड बाई टू, देन अगेन लॉग के फॉर्म में आ रहा था. फिर अगेन यहाँ पर हम लोगों ने क्या देखा? रूट अंडर समथिंग, n टू द पावर 1 अपॉन 2, n टू द पावर 1 अपॉन 5, है ना? तो रूट जब अप्लाई हो रहा था, अगेन n इज हैविंग बिगर नंबर एंड इट इज गोइंग टू रीच टू द 1, मीन्स छोटा हो रहा है n 1 by 1. देन अगेन हियर यू कैन सी आई स्क्वायर पावर, आई स्क्वायर के फॉर्म में. so it will again increment. So initially I is 2, initially I is 2, then this condition will check. Just you can assume n as a very large number, any large number you can assume. So first time it is 2, next time 2 square, so it will become 4. Next time again condition check, 2 square, it will become 16. Next time again square. So that means what is happening here, 2 to the power 1, 2 square, 2 to the power 2 square, right? Because 2 to the power 4 square is 16. Now next time 16, now I is 16, 16 square, so that will be 2 to the power 3, because 2 to the power 4, 4 to the power 8 will be the same as 16 into 16, right? So this way you can see 2 to the power 1 is nothing but 2 to the power 2 to the power 0, 2 to the power 2 to the power 1, 2 to the power 2 to the power 2, 2 to the power 2 to the power 3. This way you can see this I is trying to reach to n. So and so on. So kitne number of times this step is going to happen, kitne number of times? So let's say k times. So 2 to the power 2 to the power k equal to n. If you apply log on both sides, so it will become log n base 2, and here log 2 to the power k base 2. So finally it will become 2 to the power k equal to log n base 2. Now if we again apply log on this side, so it will become log 2 to the power k base 2 log n base 2 base 2. So this will become k equal to log n base 2 base 2. So we can say time complexity is going to be big O of log n base 2 base 2, right? अभी यहाँ पर आप लोग यहाँ पे ध्यान दें. So first this, the first log is based on these two. First log is based on this value of I 2, and the second log contribution is from this. Second log is based on this square. Example number 14. Mean I equal to 2 while I less than n. I equal to I to the power 25. Tell me the time complexity of this code. See, again यहाँ पे देखें I is starting from 2, next time 2 to the power 25. So whatever this number will become, again 2 to the power 25 square, then again 2 to the power 25 cube, and so on. कब तक? जब तक ये n को नहीं रीच कर जाता. So that means 2 to the power 25 to the power k equal to n. And to solve this, we can apply log on both sides. So what we can do? Log n, and here log 2 to the power 25 to the power k base 2, that is by base 2. So it will become 25 to the power k equal to log n base 2. Then again we need to apply log. So log 25 to the power k base 25 equal to log n base 2 and log 25. So this term will become k equal to log n base 2 and base 25. So we can say the time complexity of the given code is big O of log n base 2 and the base 25. Let's say the n is starting from 5 and I is I square I to the power 21. So what will be the output, what will the time complexity of this code? It will be big O of log n base 5 base 21. Example number 15 is main for I equal to 10, I less than n, I equal to I to the power 5. For j equal to n, j greater than 1, j equal to j by 100. And then for k equal to 2, k less than n to the power 7, k equal to k plus 9, and then x equal to y plus z. So this is our code. Now you need to try to find the time complexity of this code. Okay, and put your answer in the comment box. So see, till now we have covered plus, minus, divide, multiply, root under and square. So यहाँ पर देखिए स्क्वायर है ना, तो इसको देखते ही आपको क्या समझ में आ रहा है कि अच्छा 10 स्टार्टिंग फ्रॉम 10 और ईच टाइम आई टू द पावर 5, आई टू द पावर 5, आई टू द पावर 5. सो इम्प्लीकेशंस क्या है? फर्स्ट लॉग विल बी बेस्ड ऑन दिस and the second log will be based on this 5. So it will become log n base is 10 and the second base is 5. This number of time this loop is going to execute. Inside this you can see here j equal to n, j is having n and j greater than 1 each time j by 100, j by 100, j by 100, right? Initially j is n, each time j by 100 and it will reach to 1. Each time divide में क्या आता था? log, right? So it will become log n because j is actually n base 100, right? If you see this third example, k is 2 and each time k is plus and it will reach to n to the power 7, right? So if you see here, it is going to reach n to the power 7 upon 9 times this statement is going to execute. N to the power 7 upon 9 times. So if you talk about total time complexity of this code, so it will become log base is 5 log n base is 10 because first log is based on this, second log is based on this 5 into log n base 100 into n to the power 7 upon 9. So this is our actual time complexity. Okay, what we can do, we can ignore this 1 upon 9 into n to the power 7. So that is why it will become, we can write log n base 10 5 into log n base 100 into n to the power 7 big O of this. Let's have some more example. So let's say we are having a program like main, and let's say p equal to 1 and then for I equal to 1, I less than n, I plus plus, then p plus plus, then q equal to 1 for j equal to 1, j less than p, j equal to 2 into j, q की क्या वैल्यू होगी? प्लीज ट्राई कीजिए So see, first time this p is having 1, p variable is having 1, right? But here you can see I, this loop I equal to 1, I less than n, I equal to 2 into I, means first time this I is 1 and it is reaching 2 into I, 2 into I, 2 into I, 2 into I, and it will reach to n. So that means this p is going to execute log n base 2 times. This p is going to execute log n base 2 times. So that means this 1, whatever this 1 is having, this will become log n base 2 value, because उतने number of times ये increment happen हुआ, right? And now you can see here the q is having 1, and here you can say j equal to 1, j less than p, j equal to 2 into j, means j is starting में 1 रख रहा है, and then j by 2 multiplied by 2, j multiplied by 2, j multiplied by 2, j multiplied by 2, and so on, and it will reach to p, which is actually ये p है क्या? Actually this p is what? This p is nothing but log n base 2, because log n base 2 number of times this p increment is happened, so it will become log n base 2. And this condition, this j is less than p, is nothing but this j is less than log n base 2, right? So because already log is there, or you know that this मल्टीप्लिकेशन डिवाइड एंड मल्टीप्लाई क्या होता था, पहले इन था तो log n बेस 2, अभी log है तो log n बेस 2, फाइनल आउटपुट विल बी log n बेस 2 बेस 2. एग्जाम्पल नंबर 16, मेन p इक्वल टू 1 फॉर I equal to 1, I less than equal to n, I plus plus. For j equal to 1, j less than equal to n, j equal to 5 into j, p equal to p plus n. Now you tell me please p का वैल्यू क्या होगा after execution of this code. So here you can see the p is initially having 1, right? And this loop I equal to 1, I less than equal to n, I plus plus, that means I is starting with 1, and by incrementing each time 1 1 it is going to reach n. So that means n times this loop is going to execute, but for each I this many work is going to happen. So that means j equal to 1, j less than equal to n, j equal to 5 into j, 5 into j, that means log n base 5 times this loop is going to execute, log n base 5 times this loop is going to execute. So that means when I is 1, so it will increment p like p plus n plus n plus n and so on plus n, कितने number of times? So log n base 5 times. So when I is 1, p is incremented log n base 5 times, log n base 5 times n. So that means n into log n base 5 times. Actually p की value will become n into log n base 5 times, because n plus n plus n plus n कितने times? Log n base 5 times. So p will contain n into log n base 5s, right? When I is 1, n into log n base 5. When I is 2, again n into log n base 5. When I is 3, again n into log n base 5, and so on. When I is n, again n into log n base 5. So finally if we add all, it will become n square log n base 5. So finally the value of p will become, after completion of this loop, after termination of this loop, when the control will reach here, it will become n square log n base 5. If we talk about the time complexity, so it is going to be n times this loop and log n base 5 times this loop. So it is going to be n into log n base 5, big O of n into log n base 5 times time complexity, and the value of p will be n square log n base 5 times.